Alright guys, so now we're going to go over something called sets. We're going to go over sets. Alright, I already went over this in another video, but I'm going to go over sets. And then after that, I'm going to go over stacks and queues. And then I'm going to go over graphs. And then after that, I'll start another series on algorithms. I'll start like sorting series and stuff like that. Okay, so what is a set? Basically in math, sets are pretty much the same thing as they're in math. There's pretty much no duplicates. All right, no duplicates. That's a good thing about sets. There's no duplicates. One thing that about in mathematics, sets are unchanging, right? But in computer science, sets are manipulated by algorithms to grow or shrink over time. So we call these dynamic. Dynamic. So that means they could grow or shrink over time. Okay? And it depends on whatever type of algorithm that allows us to do things. So typically the algorithms that we use for sets are three things. Okay? So there's three simplest things you need to know in order to actually call these things. One is the ability to insert an element. Inserting an element. The second one is the ability to delete an element. Delete an element. And the final thing is to test if it's a membership. So what do I mean by membership? It just means test, does there exist something? So does there exist a value in the set? Okay, so the dynamic elements that support these operations, so all these operations, if a set supports all these, we call these dictionaries. Okay, we call these dictionaries. So if a set supports all these operations, we call them dictionaries. All right, dynamic set. By the way, yeah. Otherwise, other algorithms have more complicated things, which we'll introduce later on. Okay. All right. So typically, there's dynamic sets have elements represented by objects which could be manipulated with pointers and stuff like that. And also to identify a certain object in a set. So let's say I have this giant set of, I don't know, a set of people. Let's say I call this people. And I have a bunch of people, right? Well, in order to identify each person in here, I'll just have to have them, I label them as keys. Keys. Okay, so because of this, all keys are unique in order to label these. So these are all keys. I'll call them like key 1, key K1, key 1, key 2, key 3, key 4, key 5, so on and so forth, right? These are just like keys that tell you that there's names of whichever objects or elements in this set. And they are unique, right? They are unique. So the key for each object to identify the objects are different. Okay. So object can also contain satellite data, which are carried in other object attributes, but are unused by the set implementation. So yeah. So each object can have like data about other objects, but that are totally unrelated to each other. So that's what we call them, satellite data. All right. So yeah, that's pretty much sets. Some dynamic sets are ordered, are drawn totally, where the keys are totally ordered. So sometimes they order them by like alphabetical order. Alphabetical order. So order the keys. The keys are ordered alphabetically. Sometimes they're not. Maybe if there's numbers, it's like sorted order. Sorted order if it's numbers. It really depends on what set it is. It's not like a specific set has to have certain these like types of attributes like this. Okay, now let's go over the oh yeah. So ordering allows us to define the minimum element of a set or the maximum element of a set. So like ordering allows us to define minimum element or max, right? If I have a certain ordering of the keys, I could tell if it's a minimum element or a maximum element, okay? So like that's just how it works. Now let's talk about the operations on a set. So let's talk about operations on a set. So what are the type of operations you could do? Well, you have to, these are called like, there's two types, categories, which is one is querying, which is just returning an information about an element, querying. So there's two type of operations, querying, which is like giving you information about an element. About the set. Well, the set, actually, in CLRS, they call it, it's the set. So giving information about the set. I hope you guys can see this. Wow, that's really bad handwriting. Information about the set. The other one that you do is modifying operations. So what does that mean? This just changes the element in the set. Okay, so those are the types of operations you could do on a set. There's two types of categories. Okay. So yeah, here's are some things that should be implemented in sets if you're going to implement things. Searching for an element. Does it contain something? So like if you have like the set S and then your key K. So this is like the set, and this is like the key. This returns it if there's an if there's an element of this key in a set. So it returns an element if has the key in the set. That has the key in the set. Otherwise, it gives null. Another one's inserting, which is just inserting an element into the set. I'm not gonna write that. It basically just inserts the element into the set. You can also delete an element, deleting. So it deletes an element in the set. Minimum would get you, if it's an ordered set, it would get you the minimum element. Maximum would get you the maximum element. And yeah. Now there's these two interesting ones. There's two interesting ones. Let's call these successor and predecessor. So what does a successor do? So you're given an element in the set, right, whose key is from a totally ordered set S. It returns to the pointer of the next larger element in the set, right? So so let's say if this is ordered, so it just returns the next larger element. So like let's say if I had like a set of 1, 2, 3, 4 elements, and then let's say I want to, and I give it the element 3, the next larger element would give me 4 because it's the next larger element, right? This is assuming it's ordered. And we also have a predecessor. Predecessor. And what does this do? This just returns you to the next smaller element. Okay, returns next smaller element. So let's say if I have like 1, 2, 3, 4, and I give you 3, it would return me 2, right? So if I had like predecessor this 3, it would give me 2. Okay. So if in successor, if it's the maximum element, it'll return null. By the way, I forgot to add that. If X is a maximum element, return null. And then if it's not, for predecessor, if it's minimum, if X is minimum, it would return null. Okay, so that's a thing for predecessor and successor, and that's a thing for these operations of a set. So in some situations, we could extend the successor and predecessor to apply to non-distinctive keys. So there might be, I don't know, it depends on what type of set, but in some languages, you might have keys that are non-distinctive keys. So like you might actually, there might be multiple sets, right? Where the values are not, where they allow duplicates, right? There might be, I don't know, there are some sets like that. But yeah, but generally a set doesn't allow duplicates. The keys are all unique. And yeah, so depending on which type of structure, you could do things like this. So for dictionary objects, operations of searching, insertion, deletion, they normally do something called hashing, which like hashes the specific key to a specific value, so it has a good space and you can look things up quicker. I'll go over that later in the next videos. But yeah, sometimes they use binary search trees to implement sets. Typically that would take log of n time in order to do things, but that I'll go over, we already went over binary search trees, yeah, right? So yeah, some implementations just use arrays. So you could use an array to implement a set typically. Just like create these functions like this and just make sure that the you could insert, you delete, you could have the max and minimum, get the predecessor, successor, stuff like that. Sometimes you could also, there's also other types of data structures that support these, but yeah, that's all you have to know about sets, pretty much. Well, can you guys see this? Yeah, sorry. That's all you have to know about sets. We'll go over like what maps are. So maps are pretty easy. Pretty much maps are just like mapping a specific value to another specific value. So it's just like maps one value to another. Right. So it's just like so like let's say I have like a group of students IDs and then I have their names. I can map a specific ID to a specific name, right? That's what maps are. Maps like one value to another. Let's say I have like I don't know. Let's say you have like a bunch of colors, people's colors, and then the types of shirt that they wear, right? You can map specific color with the type of shirt that they wear, stuff like that. Depending on the languages, maps can also occur where it's like some of them don't allow duplicates, where you give like a specific key and a value, and the keys have to be distinct, right? Some languages, they override the key if you add a new map that has the same value as one another. So yeah, generally you map a specific key with a specific value. So yeah, you map one value to another. You don't normally map a specific key with a value. So if I'm going to map the people's names with the type of shirt they wear, I would map like their names as a key and then the type of shirt that they wear as their value, right? But yeah, keys generally are unique. So generally the keys that you map are no duplicates, right? And there's unique. It's you can't just have like the same person with the same say two different people with the same type of value, right? Generally, because it would like override it. But yeah, that's pretty much what maps are. Also, I'll go over all these types in C++. So I'll create another video series on all these data structures and their specific outcome in C++ and how do you use them in STL. I'll go over that. And yeah, that's pretty much it. I'll also go over that in other videos as well. But yeah, this is just a video on brief intro on sets and maps. Hope you guys enjoyed this video. Rate, comment, subscribe. I'll check you guys later. Peace.